Hello, fifth grade. I just wanted to take a short little bit to explain once more time how to do the conversion for Celsius to Fahrenheit, just to help maybe give a little bit more detailed or slower explanation than we're able to kind of get during our meeting times, and just allow you to have some practice problems to work with, so that you can have a longer detailed explanation if that helps kind of you connect better. So what we're doing here is we're going to practice how to convert from a Celsius degree, where they give you the temperature in Celsius, so I know what the temperature is in Celsius, to Fahrenheit. So we have Celsius, we're going to Fahrenheit. And when you're doing this in the book, they're always going to be giving you, from what I can see, in integers of 5 or 10s. So it's really easy to cancel out and get whole numbers that are really easy temperatures to find once we're familiar with the process, okay? So say I'm telling you we have a temperature outside that's 20 degrees Celsius. So 20 degrees Celsius. So my word problem, maybe it tells you in a long sentence, or maybe they just give you 20 degrees Celsius equals blank Fahrenheit. But I know that they need Fahrenheit, and I have the Celsius. So now I'm going to go get my formula. And a lot of times with your math books, because we're just starting these type of things, they're going to give you the formula. So for this, the formula is F equals 9 over 5, or 9/5, C plus 32. And the reason we add 32 here at the end is because of the freezing points. Celsius's freezing point is at 0, and Fahrenheit's freezing point is at 32. So when we do this conversion here, where we do our multiplication process with our fractions, that gets us to the number to relation to freezing point for Celsius. But then we have to add the 32, which accounts for the difference of that reference point of where freezing point is between the two various scales. So the first thing to do is, I know that I have a letter next to a fraction, and I know that if I have a letter next to any other number, or even another letter when you get to more advanced work, that's always going to mean multiplication. And I know that this C represents Celsius. And what's my Celsius here? 20 degrees. So I can rewrite this equation. F equals 9/5. And I know that they're right next to each other, so it's going to be multiplication. So 9/5 multiplied by, and I have 20. And then plus 32. And I know here, because I know fractions, and we've been practicing fractions this year, I cannot multiply a fraction by a whole number. So I have to turn my whole number into a fraction to be able to do this multiplication part of this problem. So anytime I see, when I've taken this from here, I plugged in my temperature, which is down here. My C has now turned into 20 because I've been given 20 degrees Celsius. But I can't go any further until I make this a fraction. And the easiest, simplest way to make a whole number into a fraction is just to put it over 1. So anytime you're doing these equations for conversion of temperatures from Celsius to Fahrenheit, when I plug in my degree here, so I replace my C with what the degree Celsius is, 20, I'm just going to put that number over 1. So now I have two fractions, and I can work with this. So I know a really easy way, I could go ahead and do my multiplication straight across and then have to simplify, or I can cancel, which is where I look diagonally to see if I can divide these numbers by the same number. And if I can do that, then I can make smaller numbers, so then when I multiply across, I don't have to simplify at the end, and it makes it easier work, because I'm doing it kind of in little chunks here and there. So I know that I have a 1 and a 9. I can't cancel this out any smaller because this is a 1. I can't go lower than 1. I can go lower than 5, though. So let me look 5 and 20. And with your book, like I said, how they're doing these degrees in 5s and 10s, you're going to be able to cancel almost every time with the problems they're giving you. They won't give you harder stuff until you get into next year and stuff like that. So 5 and 20, I'm going to say, what's the biggest number that I can divide both 5 and 20 by? Well, I could do 1. If this was a different number, maybe I could do some other things. But I know that I can divide 5 by 5, and that's going to give me 1. And I can divide 20 by 5 as well. So 20 divided by this 5 is going to give me 4. So this is my cancellation process. I'm going through and I'm seeing, can I divide both these numbers by the same number? And the biggest number that I'll be able to divide by, if I can, is by this bottom number. And in this case, I can, because both 5 and 20 are divisible by 5. So now I have, let me rewrite this fraction, 9 times 4 on the top, and then 1 times 1 on the bottom. And with multiplying fractions, once I have them both as fractions, I can just go across. So 9 times 4 is 36, and 1 times 1 will always be 1. So now I have 36 over 1. And like I did up here with my 20 over 1, I know that anytime I have a number over 1, I can just take away my bar and my 1, and my whole number is 36. So now we've gotten through the hard part. Let me get rid of this problem here, this portion here, because I'm running out of room. But I know my whole number is 36. And that's going to replace this whole chunk because I just solved for this multiplication problem. So now I have f equals 36, which is what I just solved right here for this multiplication problem. And now all that's left to do is add 32. So now I do Fahrenheit temperature equals, I have 36 plus 32, which is going to give me 68 degrees. So this is how you do that process of going from I have my Celsius degrees, I take my number for Celsius, and I replace my C with that number, which gives me a whole number. I put it over 1, so I have 2 fractions. I'm going to cancel. Once I've canceled, I'm going to multiply across, and that's going to give me a number over 1. And then I'm just going to get rid of that 1, and now I'll have a whole number, which is what this 36 is. This 36 is my whole number, and then I finish out my equation up here, because I replace and solve for this portion. Now I'm going to finish out by adding my 32. So I have my fraction multiplied number, 36 plus 32, and that gives me my answer. So whenever I'm reading this equation, I see Fahrenheit is going to equal whatever 9/5 times the Celsius temperature number that I'm given, and then that answer added by 32 will give me this Fahrenheit temperature. I solve through these steps, and then I see down here my answer when I've got it all said and done is that the Fahrenheit temperature equivalent of 20 degrees Celsius is 68 degrees Fahrenheit. And let me give you some quick ways that you can, or some quick little problems that you could practice with using our equation. And then we'll wrap up. So I would like you, if you want to feel like you need some more practice, we have these various degrees that I want you to try to solve for. So here's the 3. So you can try to solve for 15 degrees Celsius. So they give you 15, plug it into your formula and see what the answer is. 25 degrees Celsius, same thing. And then see if you can do 40 degrees Celsius. And if you need help, you practice all of these and you're not quite sure if the answers are right, talk with me when we have our teacher time and we can check those answers for you and make sure that we understand it correctly. That's all.